So this is our part figure 1 circuit manual calculation. So I declare this as the R1, R2, R3, and the R4. So this the E is this one, the potential voltage difference, and this order item. So I calculate this. Calculate first the parallel resistance. I get this one, and I get the total of the resistance first. So based on total resistance, I can find the IA from here. So I can use the E equal to IR, and I get the IA. So once I get the IA, I can get the VA by this formula, and I can get the VA is 4.71. And since the VA are the E, the VB are the E minus the VA, we can get this one, and the B can be this one. So we use a V equal to IR, and the C is actually equal to the IA equal to IB plus IC. So we can use this formula to get the item. So this is our manual calculate, and our similar value you can see it here. So let me start the simulation. You can see it here. You can see all the result. I'll be writing it like this one. I already connect and record the result like this one. So you can see that there is not much difference between our calculation value and the simulation value. So that means that I have success to simulate the result. So for the second one, this is a bridgestone bridge. Okay, so this I also declare it after R1, R2, and R3. And based on the scales, I have already written up the R port based on the sensitivity and 0 to 10 per unit scales. Okay, so how the simulated voltage and other the simulation current are measured. So like this one. Okay, since the potential meter are not able to know the scale from 0 to 10, so what I do is before we calculate, so we need to set the scale to 0. Then how to set the scale to 0 is we see this R port. We turn the potential meter to this scale. For example, I use the ohmmeter to measure from here to here. Okay, let's start the simulation. I can see now it's 0 ohm, and I can just directly like this one put to the 2.5 KL, which is the scale 1. So once I do this one, I can stop the simulation and I connect the item back. So let me connect it back. Okay, for one. Sorry. Okay, I already connected. Then we can see so the MV, and we can change it to the ampere. Then we can see the ampere. Okay. So like this one, the ampere is okay. We need to press this one, then we can get the ampere because we need to open the switch. And press this one, you can get the voltage. Voltage is how I got the voltage and also the current by this result. It's a pedometer, and this one is the resistance, the 9V battery. This one is a switch, easier for me when I want to change the scale. So you can see this our simulation voltage. So you can see for the 7, it nearly comes to the 0. So we can know that in this one, that meet the balance state. And this one is my manually calculated balance state, and is like the R port will be the 17.17 KO. And based on this graph, I can see that it's nearly like to the 7. So the manual calculation will be this one, and simulation is also the 7. So that's me already correct. So this is my graph of resistance against scales. One, if I reach current versus R port, and using the map plot to do it, you can see we can reach the difference. Okay, also, and this one is the reach voltage versus the R port. So that's all for me. Thank you.